All right, mathletes. So in this video, we're gonna only concentrate on the critical value method, okay? And then I'll do another video talking about the p-value method. And again, some of you have to do this by hand. Some of you are gonna have to use your z-table. Today, what I'm gonna do is I'm gonna look at using our TI-84 calculator to help us out. But again, the same process goes whether you're using a table or a calculator, all right? So if you're interested in how to use that table, just let us know, comment down below, and we got you, all right? So let's look at this problem and let's set up the scene. All right, so you got the American Automobile Association reported that the mean price of a gallon of regular grade gasoline in LA in 2017, January 2017, was $2.82. All right, so that was the mean. All right, so what they're telling us is we're looking at a certain point and this is our average. Then what's happening is, if we continue reading, they take a simple random survey, a simple random sample of 50 gas stations in LA, and what they found was that the average price was $2.77 from this sample, right? And again, same type of grade of gasoline. So assume that the standard deviation of prices is 0.15, and so the standard deviation that they're talking about here is the population standard deviation, and that's going to be important because that's going to be the difference in you taking a z-test versus a t-test, right? So in this case, because of that population standard deviation, right, we have the standard deviation of the population, and because you have sigma, what that's going to tell us is we're going to use a z-test here, right? So that's the biggest difference between this section and the next section that you would cover, right? So in this case, an economist is interested in determining whether the mean price for all LA gas stations is less than $2.82. All right, and we're going to use the critical value method, and they give us an alpha level, right? The level of significance in this case to be 0.05, a very common level there. All right, so let's set up the scene. So the first thing we want to do is set up our hypothesis, right? Our null hypothesis, right? Our null hypothesis. And what we're saying is that the mean is no different, right? It's equal to $2.82, right? That's what we stated in the beginning. So that's what we're saying, right? It's going to be no different than that. But when we went ahead and we took that sample, we saw something that kind of got us thinking. We saw that the average price of that sample was less than $2.82. So we're thinking, you know what, maybe actually the true mean is less than $2.82. So what we go in here, and that's what we want to look at, is the true mean actually less than $2.77. All right, is it less than that? That's what we're looking at. Okay, so that's the big question. And if we have enough information, we're going to reject this, right, the null hypothesis, and we're going to say, yeah, you know what, we have enough evidence to show that the mean is actually less than, the 282, excuse me, right? That's what we're trying to show, the 282. All right, so that 277 that I accidentally put there, that came from our sample, all right? So that gave us the indication, right, the idea that the mean is actually less than what we're claiming. All right, we're not saying it's 277. That's just pushing us in the direction to say, you know what, I think it's less than that. All right. So that's an idea. When you're setting this up, what I like to tell the Dr. Mathletes all over the world is, draw your bell-shaped curve, your normal distribution here, right? So just so we get an idea. And there's so many different ways we could look at this, all right? And so what I'm gonna plot here is I want to look at this using our z-scores, right? I want to convert this, I want to standardize this, looking at our z-scores, and we know zero's in the middle, and people usually struggle on, is this a left tail, is this a right tail? Well, look at our alternative hypothesis. We want to show that the mean is actually less than, right? So when we talk about less than, we know we're dealing with a left tail test. If this were greater than, then we would be looking at a right tail. If this were not equal to, that's when you would have both tails. So in this case, we're going to have this area, this left tail, and this area is going to represent our level of significance. So it's 0.05. So the first thing I tell people to do is kind of set up the scene here, and then we're going to go dig for more information, right? So this is our first step. Got it? Good. Follow me to the second part of the process. All right, so now that we have our drawing, the next part, what we're going to need to do is get this critical value, right? This critical value right here. And I call it like my cutoff point, right? Because this is going to help me determine whether I'm going to reject H0. This critical value that we're going to find is going to be a big part to determining if whether we reject H0 or not, right? So how do we find this critical value? All right, so this is what we do. Go ahead, take out your calculators, and we're going to use to find the critical value, I'll call it CV, we're going to use the program inverse norm, norm from our calculator. So how do we find it? Let's go to my calculator. All right, so let me record this so you guys could see. All right, so we go to second vars here. All right, so we go to second vars. Let me do that again, turn on my calculator. Second vars, and then I'm using number 4 here. Sorry, number 3, inverse norm we said. Inverse norm, inv norm, right? Go ahead, hit enter. And in my calculator, it doesn't give me the option of left, center, or right. So what my calculator is assuming is I'm gonna give it this area to the left, right? And notice if this were a right tail test, the area that I would punch into my calculator would be the right area. So I would do 1 minus, say, 0.05. But here, this is nice because I'm trying to find the left area, or I need to give the calculator this area to the left, and that's what I actually have right here. All right, so the area I'm punching in is 0.05. Again, if this were a right tail, I would punch in 1 minus 0.05, which is 0.95. All right, my mean, since this is a standard normal curve right here, is 0, standard deviation of 1. So we'll hit paste, and we should already know, because we've used this number over and over again, that our z score here, right, our critical value here is negative 1.645. All right, so what that tells me, right, and again, we use inverse norm, the program, to get the critical value. And what this tells me is if when I go and calculate the test statistic, which what we're going to do right now, right, that's next, depending on where that test statistic lies, if it lies to the left of this cutoff point, my critical value, if it lies to the left over here, what that's going to tell me is I reject H0. This is my rejection region. All right. So again, if it falls to the left of this in the shaded area, that's my rejection region, and I'm going to reject H0. If it falls anywhere over here to the right of this number right here, my critical value, what that tells me is I'm not going to reject my alternative, right? My alternate hypothesis. So again, very important that we understand, number 1, how to find these and what two values we are comparing. And that's using this critical value method. All right, so now that you know how to find the critical value, let's go ahead and calculate that test statistic. Follow me. All right, so just like we said, we need to go ahead and calculate our test statistic. And this is our formula, just the same formula we've been using, right, as before, to calculate our z value here, in this case, our test statistic. So we're just gonna plug everything in, right? So let's go ahead and plug in these values. Our x bar that we found in this case was 277. Our mean that we're using is 2.82. Sorry, that's messy. The standard deviation for the population here is 0.15, and we're dividing by the square root of n, and in this case, we looked at 50 gas stations. So again, this is a 2.82. Sorry, I'm trying to squeeze everything in here. All right, so let's go ahead and pull out your calculators. If you're gonna do everything in one shot here, a lot of people make calculation errors when they're doing this. So just make sure you're very careful and you're plugging, if you're doing everything at once, make sure the numerator is in parentheses and make sure your denominator is in parentheses as well. All right, if not, you're gonna see your answer is gonna come out to be wrong. So this is if you're doing it by hand, right? Some of your instructors are going to want you to do it by hand. If you don't do it by hand, you could use the program Z-Test, and Z-Test will give you the same answer. And when you're using Z-Test, the only thing you got to make sure is all these variables that you're entering in are correct, and then make sure you're choosing the less than. So I'll show you that in a few minutes so that we could check our work here. All right, so let's go ahead and plug this in, and I did the work already for us, and so I'm getting negative 2.36 for our test statistic. All right, so now let's go ahead and use that program Z-Test just so you could see how the calculator will also give you this value right here. All right, so let's see how we do this in the calculator if you're interested. All right, so let's see how this program works. So in our calculator, we're gonna click on stat. All right, so click on stat, then go over to test, right? And you're gonna pick this top one, which is Z-Test, that very first one, all right? And make sure that stats is highlighted here because we don't have data is when they give you the list, right, of information. We don't have all that information. They just give us the statistics. So let's enter in all that information right here. So our mean, that population mean was 2.82, right? Well, that's our null hypothesis right there. That's what we're challenging. Our population standard deviation is 0.15. Our X bar, right, sample mean is 2.77. How many samples did we take? We looked at 50 gas stations, and make sure it's less than, right? So you're choosing the less than because that's what we're looking at, a left tail test here. And let's go ahead and hit calculate. So let's go ahead, go down to calculate. And what we're interested in is the Z value here, right? So we're getting our test statistic. That's what this gives us. We have calculated our test statistic, which is negative 2.36, which is exactly what we got when we did it by hand. And in our next video, we're going to be looking at doing this using the p-value approach. And this test right here, this program also gives you the p-value, and we'll talk about that later. All right, so again, this program is a great way for us just to confirm or to actually run the numbers for you. All right, so what do we do with these numbers? Well, let's take a look. All right, so now we have our test statistic. So what we do is we say, where does this test statistic lie, right, in our distribution? So here's our critical value, and we see this is to the left, right? This number is to the left of our critical value. So I'll just say this lies right here. And what we see is everything in that shaded region tells us to reject H naught. So what we're doing here, this number again falls in this side region, right? Because it's less than negative 1.6. So what that tells us is that our test statistic lies in our rejection region. So what we're doing is we're going to go ahead and reject H naught. So we have enough evidence, right? Sufficient evidence to accept this claim right here that the mean, right, of gas is actually in LA, in this area, is less than $2.82, right? We've demonstrated enough evidence here to support that claim right there. So you would just write in conclusion, right? Using the 0.05 significance level, we have enough evidence, right? Sufficient evidence to support the claim that the mean price for all gas stations is less than $2.82. And that would be our conclusion right there. So let's actually go ahead and type it up, because a lot of us, right, as we're learning this, we're kind of struggling with the language. So let's go ahead and type that up for our viewers, and let's do that right here. So at the 0.05 significance level, you always want to tell your audience, you know, what was that level? How significant is it? So at the 0.05 significance level, we have sufficient evidence to support the claim that the mean price for all, I'll just put LA gas stations, is less than $2.82. All right, mathletes. So there's our conclusion right there. So kind of doing a little recap, right? Everyone's going to have their own method of how they want you to go about doing this. Let me bring this up so you guys could see that. Let me make this a little bigger so you guys can see everything I wrote. All right. But let's go over what we did. Well, number one, you need to write your null and alternative hypothesis, right? And then based on the information that they give you, right, you're going to use the level of significance to help you find your critical value, that cutoff point, right? Because what you're going to do is after you have that cutoff point identified, then you're going to go and find that test statistic. And that test statistic is going to tell us what to do, right? It's going to tell us, do I accept the claim? Do I have enough evidence to reject the null hypothesis, right? Am I rejecting this? Or do I not have enough evidence to reject that? And remember, just because we don't reject it, say that was the case, right? That's not saying that this is true. It's just saying we don't have enough evidence to show that the opposite, the alternate case is true. So again, a lot to think about here. So hopefully this was helpful. And if it was helpful, do us a favor, tell a friend, right? We're trying to grow the channel here and help as many mathletes as possible. And if you want an example, another example, let us know down below, right? We're all ears. We're trying to help you succeed in your math class. So again, hopefully this was helpful. Do us a big favor, smash that like button, subscribe, and we'll see you mathletes in the next video. Peace.